So on this problem we have a radical on both sides, and the problem is that we have a plus 1 on the outside of a radical. So of course whenever we want to get rid of a square root, we square both sides. And the thing is, we end up with a binomial squared on this side. Over here it's cake. Your answer ends up being 2x plus 5. That's easy. But the left side is where it gets more challenging, because you have to actually write that out twice and distribute. This is what I mean by writing it out twice. You have that binomial written twice, and you're going to have to distribute. So when you go this radical times that same radical, it ends up eliminating the radical, and it just gives you the value inside the radical, which is x plus 2. I hope that makes sense. Whenever you have a radical and multiply it with the same exact radical, the square root disappears. All right? The square root of 3 times square root of 3 is just 3. The square root of 7 times square root of 7 is just 7. That's the answer. So the square root disappears. But we still need to continue distributing. How about the radical value x plus 2 times 1? Well, that's going to be one of those square roots of x plus 2. Let me zoom out a little. And then let me distribute 1 times the square root of x plus 2 again. That's going to be another one of those square roots of x plus 2. And last but not least, 1 times 1, that's going to be just plus 1 at the very end. So I still need to combine like terms. If I combine this term with this term, think about it. That's like saying one of these radical values plus another one of those same exact radical values. It's simply going to be 2 of those radical values of x plus 2. It's like saying I have one apple plus another apple. It's 2 of those same apples, right? I'm going to bring down everything else. I'm going to bring down the x, the plus, the 2. There's a plus sign here, and even the plus 1 that's on the outside at the very end. And I'm still going to combine like terms. There's this 2 right here that I want to combine with this 1 over here. So let me rewrite my final simplified right side of the equation here. It's going to be a x plus 3, because 2 plus 1 is 3, plus 2 square root of x plus 2. And let me bring down the equal sign. Let me bring down the left side, 2x plus 5. Everybody with me? Okay. So I now have one radical value. So we started out by having a radical on the left side and a radical on the right side. Now we only have one radical, and it's on the right side. Let's isolate it. Let's get it by itself. So I'm going to subtract x, and I'm also going to subtract 3. 2 steps in one. Subtract 3. So, of course, over here, x take away x cancels, 3 take away 3 cancels. But on the left side, I end up with 2x take away 1x. That's just 1x left over. 5 take away 3. That's a plus 2. Bring down the equal sign, and bring down what's left on the right side. That would be 2 times the square root of x plus 2. And, of course, we still need to get that radical by itself. There's still a 2 in front of there. So I'm going to now divide by 2 to get rid of the 2. And also what I do to one side, I do to the other side. I need to divide the whole left side by 2. In other words, divide everything by 2. Okay? So what I have now is really x divided by 2. What is x divided by 2? That's really just half an x. So that's 1/2 of an x. 2 divided by 2 is 1. Equals the radical x plus 2. So now at this point, I need to get rid of that radical value. How do I get rid of the radical value? I square it. So I'm going to square this side, and I'm also going to square the whole left side. Now the thing is, again, I have another binomial right here. Not only that, it's a binomial that has a fraction in it. So the right side's easy. The square and the square root cancel out. You just have x plus 2 left over. But the left side's the confusing part. because you have to actually distribute combined like terms and you're dealing with radicals. So I'm running out of space. Let me rewrite this problem. I have 1/2 x plus 1 times 1/2 x plus 1. It's awesome having technology you could write off of the board. And of course, it's going to be equal to x plus 2. And why is that? Because when you square the radical, it's just going to be x plus 2 left over. So I hope we see, whoa. I hope we see how we ended up with that new equation up there. I simply took this guy, wrote it twice, and this guy, the square root canceled with the square. So let me just focus in on this new equation that we have. And let me distribute. So 1/2 x times 1/2 x. 1/2 times 1/2 is 1/4. And x times x is x squared. And then when I go 1/2 x times 1, well, that's just going to be a plus 1/2 x. And then when I go 1 times 1/2 x, that's going to be another plus 1/2 x. And when I go 1 times 1, that's just going to be another plus 1. And of course, let's bring down the equal and also the x plus 2. And now let's combine like terms. After you distribute combine like terms, I could combine 1/2 x plus another half of an x. What's half of an x plus another half of an x? It's just 1x. So you can just put an x with a plus sign in front of it after you combine that guy with that guy. Let me bring down the rest. I'm going to have a 1/4 x squared. I'm going to have a plus 1 at the very end, an equal sign, and also an x plus 2. And now I want to move everything to one side to get x by itself. But if I think about moving this x over by subtracting x, it's going to cancel. And if I subtract x, it's going to cancel, right? So instead of moving these two guys over here to this side and setting it equal to 0, I already know my x is going to cancel with my x when I subtract them. So I will be just having an x squared left over, which means I want to isolate the x squared if I don't have any x's. Check this out. If I subtract x, cancel, subtract x. It doesn't matter if you're thinking of moving it from this side to this side or this side to this side. The x's cancel. They disappear. What do you have left? Let me rewrite what I have left. I have a 1/4 x squared plus 1 equals 2. So now at this point, it makes more sense to get the x squared by itself, get rid of this and this, then at the very end, square root both sides. Does that make sense? To get the x by itself? So that's what I'm going to do. I'm going to get the x squared by itself. Let's subtract 1, subtract 1. You're going to end up with 1/4 x squared equals 1. And then we're going to multiply both sides by 4. Cancel. So you're going to end up with your new equation. And the new equation is x squared equals 4. And for your final step, you would apply a square root. So we're not getting rid of square roots here. We're going to apply a square root to both sides. And we all know that when we apply a square root to an equation, we need to have a plus minus in front of our answer. So there's our answer, x equals plus minus 2. But we also need to go back and actually check and make sure that both of those answers are correct answers, not extraneous solutions. So let's test positive 2 first. Going back to the original, which was way over here on the board. Going back to the original, let's test positive 2 and negative 2. So again, we're going to ignore the red marks that I did. Let's look at the original. If I plug in a 2 right here, it'll be 2 times 2, which is 4. 4 plus 5, which is 9. And the square root of 9 is 3. Now, on the other side, if I plug in a 2 right here, 2 plus 2 is 4. The square root of 4 is 2. And 2 plus 1 is also 3. So 3 equals 3, we know it works, right? So we know that positive 2 works. Now let's go back and check negative 2. So if we try negative 2, 2 times negative 2 is negative 4. Negative 4 plus 5 is 1. The square root of 1, what's the square root of 1? It's 1. Okay. Now, how about the right side? If I plug in a negative 2 right here, negative 2 plus 2? 0. What's the square root of 0? 0. What's 0 plus 1? 1. So, right here, both answers work. The positive 2 and the negative 2. So you have to write both answers on your answer spot, and you could, of course, just represent it, both answers as x equals plus minus 2. I hope this helps. This is the longest type of problem you'll see on the next test. Good luck.